the way that we set up the program is kind of based on, it's a little bit reactionary, but we are very keen to kind of try to get ahead of industry a little bit. But it is reactionary to the organizational, technological, and kind of environmental imperatives that we're seeing in industry. Organizational being the sort of imperative to integrate and collaborate. Technological being the influence, in this case, of information technology and advances in information technology and tools, and then the environmental imperative of green design, high-performance building, sustainability. And all of these things are kind of a perfect storm around process. And so what we're trying to impart is a little bit about what is this process now in the delivery of buildings. And because we're coming at it from the angle of both design and construction, we like to kind of just say our program is about making buildings from the beginning to the end, and then also even into operations. But in order to kind of structure the framework in a more useful manner, we do see a little bit of hierarchy. And this is the people, this is the process, it's the management. And without the collaboration and the efficient collaboration of these people, these other things become very difficult. So we kind of hone in on that. It also happens to be, because of the nature of the school and the structure at Auburn, that has both design and construction in the same college, schools in the same college, it made sense for that to be the kind of driving thing. So that's where we start. And we really see the technologies as being the enabler of that process, and the sustainable built environment as the goal.
We want to be real careful to talk about the name of the program. The Master of Design Build is actually a title that we inherited. Some of you, or many of you, may be familiar with the Rural Studio at Auburn, which was started by D.K. Ruth and Sambo Mockbee. D.K. actually started the Master of Design Build program at Auburn about 6 years ago, and the model at the time was about community outreach, very similar to the Rural Studio, but in a different sort of environment on campus. When he basically decided to return to the architecture faculty, the college saw that as an opportunity to sort of reinvent that graduate study. Auburn, over the last 8 years, has had a lot of undergraduate collaborative efforts, many similar to some of the ones John presented earlier, and several of which have been mildly successful, some maybe not so successful. But we saw this as an opportunity to expand that to the next level and make the collaborative and integrated graduate program sort of a flagship of the effort. And so in any event, we want to be careful to articulate that although the name suggests design build, perhaps as a single source, contract procurement type perspective, and that's not really the case at all. We offer them a spectrum of project delivery perspectives. We simply inherited the name from the program.
And so it kind of hints to the imperative that we have to try to instill a sensibility about the degree of actual flexibility in practice, which is to say that there are these kind of ways of doing things. We even talk about the modicum of integration allowed by a CM at risk type arrangement. And also, these are my sort of gloss on Greg's diagrams, because I went to Auburn from shop, so I worked at shop. And so I inherited a lot of these diagrams, and also from my previous employer before that was Front. And so I saw a lot in practice these various different hybrid arrangements that weren't, you couldn't call them IPD for sure, and they weren't really design build, and they don't fit neatly, but they're just ways that people are finding to kind of to bend the rules where necessary in order to enable things to happen. And that's really what we're trying to get to the students to understand, is that there's all these things, but we want them to understand what's behind it and be able to identify latent opportunities when they can, because that's where innovation is going to happen, and that's what's going to lead us forward. I particularly, in the classes that I teach, do spend a lot of time talking about integrated project delivery, the AIA version, particularly because I think it's a potentially revolutionary way of delivering buildings, but also because if you look at its key points, it embedded in those is an inherent critique of the current way of doing things and a sort of inherent history of where we've come. And again, it's about understanding why those things are important and what's not working currently, and then also how to sort of extend that analysis into new arrangements. And so this is how we teach it as well. We have 10 students this year, 10 design track students with design backgrounds, 10 construction management students with CM backgrounds. They all earn the same degree, which is Master of Design Build, but one is design track and the other is construction track. So the setup is that they're working together. We start there. It's collaborative. The technology is the medium in which they work. And again, we have this sort of luxury because we don't have to teach them sort of foundational design principles and things like that. We can just throw them right into the deep end with BIM right off the bat. And we don't even just do it with what might be more properly termed BIM tools like Revit or something like that. We actually sort of, the expression is feed them from the fire hose, I guess, in the first semester, in that we get them to use parametric tools, analysis tools, BIM tools, explicit modeling tools. It extends into the construction side with scheduling tools like Primavera, Navisworks, structural analysis, everything. And they don't like it in a way because it is a lot to learn, but really the idea is to get them to think in those tools. So here's a quick rundown of our curriculum and the way it works, and Paul knows a lot about this.
As Josh mentioned, there are 10 students in each track, and somewhat echoing John's comments earlier about we want them to collaborate but to also maintain their own identity within their respective discipline. And so out of these 36 hours, 21 of them are actually, the classes or studios are taken together. And then out of the 21 hours, 18 of them are team taught by faculty from the School of Building Science and also the School of Architecture. And that's significant because it's an expensive way to deliver classes. It doubles the cost. We're very fortunate in that we have a faculty line and also an endowment that helps support our program, and so we're able to sort of bear the burden of those costs, so to speak. But we think it offers a really rich environment because, particularly if you're talking about topics that have multiple perspectives, particularly from the builder and the designer, then it's nice to have advocates from both disciplines in the room. And sometimes that's not always it's not adversarial, so to speak, but sometimes we disagree, and I think that's a healthy perspective for the students to see that's going to reflect what happens in industry.
Because it's a small program and it's very tightly coordinated, that we're actually also able to overlap a lot of the coursework, so that these individual, even the ones that are sort of discipline specific, end up with kind of collaborative overlap with other classes. Most importantly, the studios, because the studios, even though they exist on the design side, which is incidentally also a sort of legacy of the old Master of Design Build program, but I think it's working out well because the studio projects become the vehicle for a lot of the actual collaborative work that happens. And so they learn a lot about the issues and learn a lot about collaborative practice and its role in industry and the impact it's having in a lot of the seminar classes. But then when they get in the construction studio, they work in teams of 4, 2 designers and 2 constructors working together on the studio projects. So far beyond just working in pairs and definitely not working as individuals. And that becomes the place where a lot of the stuff kind of comes out. So it does kind of start out a little bit separate, but it evolves actually by the end into a full kind of integrated studio model where they're all together in the last semester of the program. And I just wanted to kind of step back to the framework a second because I wanted to talk about the medium, and that is BIM and the way that it kind of works in the process. Again, like I said, we see it as an enabler of the process of actually managing people and materials and the process in a social way, there's a sort of corresponding informational process that goes along with it. And those things kind of inform one another. So in a lot of ways, all of the other things that we have to do on a project, whether we're presenting it to people, whether we're doing estimation, whether we're doing scheduling, all of this sort of management aspect, all of this stuff is digital now, and it can all feed on a BIM, because the BIM kind of sits in the center of the process as the project itself, the virtual representation of the project itself. And so then it becomes both the medium for the development of the design as well as the medium for communication as well as all of these other things. And so it is kind of enabling, we see it as enabling the integration process. We are seeing some pretty good stuff coming out of it so far, and some interesting kind of anecdotal evidence that what we're doing seems to be working in terms of breaking down some of the barriers between design and construction and getting them to understand each other and to collaborate. And it's really interesting to see because often it's getting to the point, it's late in the year now, so a lot of it they're taking off on their own and they're doing things that we're not asking them to do and really understanding how to work together. So I'm going to go through a couple of projects right now. In the fall, Volkswagen invited some southeastern schools to design them a new footbridge, and we thought that the footbridge was a great kind of first project because it's a scale that they could kind of wrap their heads around. And at the same time, even though this was actually the winning entry, and they went with a tower to kind of connect two flat spans, and that actually won them the competition. But the other interesting thing about a bridge was that it wasn't a building, so they couldn't just default to making a building that they already knew how to do ahead of time. They had to kind of rethink a lot of what they were doing through the new tools that they were learning. It's just another perspective. And so all of these, in kind of keeping with the theme, like all of these images are directly out of Revit. This is a rendering from a Revit model that's been dressed up, obviously. And that's the model itself. The kind of aggregate model. A lot of these other things were designed, these panels were designed in the parametric modeling software Inventor in a different environment, brought into Revit. There's actually a Revit Structural model. Those two are linked together. This is looking at the kind of effects of the structure itself on shading the bridge and kind of an early study of the wall panels done through Ecotect.
It was really a great opportunity for the construction students, as Josh mentioned, as opposed to a building. On the other hand, it is a 20,000 square foot heated and cooled bridge that handles an 800-person shift change. So in some ways, it was a building, but with span components. The reason the bridge is there in the first place is that there was a sort of manufactured Army Corps wetland that it had to span. So, ergo, there are environmental issues that they had to consider, and so forth. And so through the model. It was really quite a fantastic experience for the construction students as well, because that gave them sort of a vehicle to study constructability, develop hoisting plans. Our kids were actually, working with Liebherr and Manawock to start to understand pick points and do they make construction joints at the verticals or mid spans and so forth. So, as a tool, the bridge really worked out well as a first project.
And then in the end, of course, they can take all of that information and put together a cost estimate of the bridge. That was our first semester, and that kind of set up the precedent. Everybody learned the software, learned what they were kind of going to be doing in terms of working together. And so in the spring and the summer semesters are actually contiguous in terms of the project that they work on. We get a project to design a library for the city of Chattanooga. Now, Chattanooga wants to design a library. They need a library. They aren't really kind of ready to go out and hire people to do that. So there's a nonprofit in Chattanooga called River City that actually sponsored our studio to develop some designs on a couple of sites that they had in mind. And so in a way, they turn out to be very, very detailed kind of feasibility studies about a library. At the end of it, they will have an understanding, a pretty good understanding of what it might cost, what the program needs to be. The students did a very detailed programming exercise because we actually had the time to do that. They'll know a rough schedule, and it'll be accurate enough that it's valuable information. And it's something that we want to keep doing in the program, is try to get quote-unquote live clients as much as we can, and utilize because the students are coming in and they already have design and construction skills, and we're building upon that foundation. They're actually producing work. And so it's one of the aspects of the old design program, design build program as an outreach program, that we're trying to maintain in a way. So you can see these are structural and geothermal systems. This is cut through the Revit model. This is another library project in a different location, and I talked about this one in my in the paper because it's a little bit of a prosaic example, but I think it's great because basically this structural model was built by one of the construction members of the team, and it was totally unsolicited. Basically, there's this large span that you can see in the rendering that he had a question about and wanted to try to figure out. So he literally just asked for the Revit model, took it into Revit Structure, and built up the structure of the entire thing so that he could just wrap his head around it, and then communicate what was going on back to the architect. And that actually had some implications on the inside of the building as well. And so that's kind of what we're talking about, is the idea that they are actually learning to kind of think through these tools, that they're not just a sort of appendage to some other design process that they have, or it's, they do one thing and then they dump it in the BIM at some point, that they're thinking through it from the very beginning. And in this case, they're thinking through it with all of the input of their construction counterparts. And so you start to develop a new manner of working that doesn't feel new, and it doesn't seem like it should be that unique, but in comparison to the manner we've been working, it is.